kubectl actually a command line tool. It is a command line tool to execute the command which will manage the Kubernetes. Okay. Then what is Minikube? Minikube is also a tool which uses to create Kubernetes cluster. Very simple, right? In the development or training platform. Okay, for development and training uses, we use Minikube. Okay, so see this particular diagram. So we know that kubectl is a CLI. kubectl is a CLI, right? Command line interface, right? To use or give some input. So what happens when we type some commands in the Kubernetes? What will happen? Through kubectl will give some commands to the API. So the API server gets the input from the client. The client is kubectl, right? And it checks the request, whatever the command executed by the kubectl. API just sends that to the etcd database. It just scans the etcd database. So etcd is the database where all the informations, the complete Kubernetes cluster informations will be stored here in this etcd database. This is a flat file database where all the informations about the cluster, nodes, pods, applications, everything will be kept here. So here through kubectl, it comes to the API server. From API server, it scans the etcd database, and once it gets back the informations from the etcd, so etcd sends the informations about what the kubectl wants to know, and then the API server will sends the request back to the scheduler. So scheduler, what will happen is the main role of the scheduler. What it does, it schedules the pod, or it schedules the container creations, deletions, everything will be done by the scheduler. So once the informations we get back from the etcd, API server sends the request to the scheduler. The scheduler, what will do, sends back the response to the API server again. What then API server will do? API server will connect to the node machines. So which node machines it will connect? The informations where it will get? It will get from the etcd database. Because there will be multiple nodes. So which node machine it should connect for the query sent by the kubectl will decide based on the input given by the etcd database, because the database will have all the informations. Then API server, what will do? Scan the API server, scan the etcd database, get the informations, and send back to the scheduler. Then scheduler, based on the input provided by the API server, scheduler will check it and connect back to the node. And then what will happen? If you want to create, suppose if you want to create some pod, what will happen? Or container, what will happen? Through network kube proxy, it is a network through which it will connect to the kubelet. It is actually one of the Kubernetes agent, kubelet agent, through which it will connect to the master. We need one agent to be installed on the node so that it can connect to the master, right? So the kubelet as the agent, it gets the request, it gets the input from the API server from master machine, right? Then the kubelet will trigger the Docker daemon. The kubelet will trigger the Docker daemon. So Docker daemon, what is the Docker daemon? It's the Docker runtime environment, right? Which uses to create and destroy the containers. So it can trigger the Docker daemon or Docker runtime. Suppose there is a creation of containers. So what it will do? It will create two pods. It will to create two pods, and that pod contains the containers inside it, right? We'll know about the pod, what is pod and all in our upcoming classes. Okay, we'll get to know about pod. So for now, just understand as container, or it creates the pods. Okay, so this is how it works. Now you'll be thinking, what is this controller does then? It is simply sitting, it is not connected to anyone. It is simple sitting, right? But controller actually the brain of everything. What it does, it will be simply sitting here. What it will do, it will keep scanning the, sorry, it will keep scanning the etcd database. Okay, so before that, suppose once the pods are created, suppose new pods are created, what will happen again? The kubelet agent, what it will do, it will get the informations back, send again to the API server, that these two new pods created with these informations, and these informations API server will write back to the etcd database. So every time there is any changes to the cluster, to the nodes, to any pods, everything will get updated into the etcd database. Okay, so all the informations will be there into. So that is how the Kubernetes works. It gets all the informations from the etcd database, and based on that, it works. Okay, so then what this controller does? Controller, it will be sitting here in the master always, and it will keep scanning the etcd database. Now we heard about the self-healing, right? What is this self-healing? Automatically, we know that Kubernetes has capability to do the self-healing, automatically heal if any pods or containers goes down, or something happens, a node goes down, right? How it will be done? It's being done by the controller. Controller actually what it does, it scans. So it is not done by the controller, but controller has the main role in it, because it will be scanning the database all the time. If it finds anything happens in the data, if in database, if any pod failed, all the informations, because it will be, if the pod failed, what will happen? The kubelet send back the information to the API, and again API will update to that. That means we have then etcd database, there will be one information that pod A has failed. As this controller is scanning every milliseconds the etcd database, right? So it finds that pod A is failed. What will happen? Controller will immediately inform. So once it get the information, it will immediately inform back to the scheduler, that there is a failure in node, this particular node, and pod A has failed. Then scheduler will again send the informations back to the API server. Then API server will trigger the kubelet here. Then kubelet will take care of this, and Docker daemon will take care of this. This is how the entire architecture or entire Kubernetes flow works. Understood, guys? I think you would have clearly understand what and how this Kubernetes works, right? Complete workflow. Do you have any doubt, guys? So this is very important, because if someone asks in your interview, you have to explain what is the role of the controller, what is the role of the scheduler, what is the role of the API server, right? Let me explain you more on this. Okay, so during Kubernetes installations, we'll find these things get installed. What is this? API server, etcd, scheduler, controller, kubelet service by agent, kube proxy, a container runtime or daemon, right? These are the things will get installed when we install the Kubernetes cluster. Okay. So what is this API server? We learned about the API server, and I said that API server does all the things, right? API server acts as the front end of Kubernetes. The users management devices, command line interface, all talk to the API server first to interact with the Kubernetes cluster, cluster, like we see this one, right? API server. Okay. Now, ETCD. What is ETCD? It is a distributed reliability key value store. It is a flat file database. Okay. Key value store means it will be stored in the JSON file, right? What will be key and value? Name, suppose Ranjit. Name is the key, value is the Ranjit. Similarly, it will be pod A. Pod is the key, equal to pod A. A is the value, right? So, key value stored used by Kubernetes to store all data used to manage the cluster. That is what I said, right? Everything, whatever I explained, that is it written here. I have written it here, right? That is when we have multiple nodes and multiple master in our cluster, then etcd stores all that informations on all the nodes, which node has which pod and which pod has goes down, which pod needs to be created. Everything will be written in the etcd. The scheduler, what is the scheduler? It is the responsible of distributing the work. All the informations, whatever received from the etcd through API server or through the controller, scheduler will decide. It will distribute the work or containers across the multiple nodes through kubectl, right? It looks for newly created containers and assign them to the nodes based on the availability. Scheduler is the responsibility to distributing the work or containers across multiple nodes. What are the controllers? As I said, it is the brain behind the orchestrations. They are responsible for noticing and responding when it is actually a kind of a watchman, right? It will be watching the Kubernetes clusters all the time. It will be keeping an eyes on the etcd 24/7. Every micro nanoseconds, it will be just scanning the etcd database. If there is anything happens, abnormality it finds, it immediately informs back to the scheduler. Then scheduler will take care. So the controller makes decision to bring up new containers in such cases. What cases? If they are responsible, what is it? They are responsible for noticing and responding when nodes, containers, endpoints goes down, right? Then it takes the decisions what needs to be done. Based on the manifesto file, based on the setups we have done, it will decide, right? Next comes the container runtime. I was talking about the container endpoint or container daemon. Those are the underlying software that used to run the containers or the pods. In our case, suppose we have used Docker, there will be different container runtimes will be available. They will be using different containers, right? So kubelet. So kubelet is the agent that runs in each node. Remember, in one cluster, there will be multiple nodes, right? So each node, there will be agents, kubelet agents installed, available, which will be responsible for the container to check and run the containers as per the requirement, right? So kubelet responsibility. Then kubeproxy, it is a networking, as I said, kubeproxy takes care of the networking with Kubernetes. Okay. You understood about all this flow, right? And in Kubernetes, we saw the etcd database is there in the master. Okay. So there are two types of topology we are going to learn, and this is very important. So what we do normally, the etcd database, we definitely for high availability, right? What do? We would create a multiple masters, right? If one master goes down, so there will be another master available to handle the deployments, to manage the nodes or pods, right? So in stack topology, what happens? You can see we have this etcd database, right? Are inside the masters. Inside the masters. So what will happen in this case? We have to always need to replicate the data each time, every time to the other master machines. So make sure in case this goes down, this should be available with all the informations what this is having. So every time everything it gets replicated here, it should be added here, it should be replicated in this etc. If it is goes down, so that it all the information should have stored here, it can handle. This is tagged topology where we keep the etcd data set in the individual master machines. But there will be another one is external etcd topology. External etcd topology. What happens is external etcd topology, the etcd, the database, right, data set will be kept outside. Will be kept outside. So what happened outside of the master? That means what will happen if this master goes down? Not a problem. This database etcd are there outside and it can manage by the master. What will happen every time the master, the API server gets all informations, it will write both the etcd. If we have multiple etcd, then it will write both them. Similarly, this masters, this. That means all the data will be up to date, right? Data will be up to date. In case of this etcd or this master goes down, this can handle easily because all the data is available with it. That is the external.